Okay, this is a hydrated salt or waters of hydration calculation. So it's very, very simple similar to an empirical formula. Always has the same idea in terms of you do an experiment where you take some sort of salt, so calcium sulfate is a salt, which contains waters of crystallization. So waters are just bonded to my calcium sulfate, and the aim is to find out how many waters there are. So when I heat this salt, what happens is, remember the dot just means it's bonded to it differently. What happens is the waters break away, leaving my calcium sulfate behind, and however many waters there are, they'll all come off when heated. So, information I've been given is I've been given mass of hydrated salts. So hydrated salts, 6.1 grams. That's the whole thing. So it's telling me I have 6.1 grams of that. Now this number in itself, I'm never going to put this straight in a calculation because there's no point really. Because if I don't know how many moles of this whole thing I've got or anything other information, I can't work anything out just from this 6.1 grams because I don't know what X is. But what I have been told is that I've got 3.4 grams of anhydrous, no water. So it's telling me that after I've heated it, I made 3.4 grams. So immediately I now have something with a formula and a mass in grams, which means I can calculate number of moles. And then over here, I can work out what the mass of whatever my water molecules are. So I've got 6.1 grams to start with, and then I lost I ended up with 3.4 grams at the end. If I do a bit of taking away, I find out that my water weighs 2.7 grams. So how is this like an empirical formula? What I'm going to do is I'm going to put, instead of putting like just the elements, so like calcium, sulfur, oxygen, mass, moles, I'm going to put formula of calcium sulfate and the formula of water. Everything else is going to be quite similar. So I have, from my experiment, mass in grams, which is 3.4 for calcium sulfate and 2.7 for water. What I'm trying to find out is the ratio, how many moles of that to how many moles of that. You might look at it at the moment and think it looks like that there are more of those than there are of those, but that's because we've got mass and we need to know what the ratio is in moles. So to find moles from mass in grams, we need to work out the RFM. So I'll have a look on the periodic table. Calcium's 40, sulfur's 32, oxygen is 16. I add it all up, and my RFM of calcium sulfate is 136. Slightly easier, RFM of water is just 2 plus 16, so that's 18. Then I've got my moles. So moles is just mass in grams divided by RFM. And so I'm going to do 3.4 divided by 136. And that gives me a nice neat answer of 0.025 moles for my calcium sulfate. Never going to have a whole mole in an experiment because that would be a lot of salt to heat. And then I do my 2.7 divided by 18, which tells me I have 0.15 moles of water. Those aren't whole numbers, so that is my ratio of moles, but as usual, just like an empirical formula, I need to divide by the smallest number in order to get one of these being 1 mole, and it should be this that is the 1 mole, so we shouldn't be having like half a water molecule for one of these. This should be a bigger number, which it is, and I recommend that you do this calculation. So there's 0.15 divided by 0.025. I recommend you do that on your calculator because sometimes you think you leap to an answer and you get the wrong thing. So 0.15 divided by 0.025 gives me 6. 0.025 divided by itself gives me 1. So that's my final answer. X is 6. If I go back to it, there are 6 moles of water produced for every 1 mole of calcium sulfate that I've got left over.